So this is Ms. Crandall here. This equation that you're looking at you may recognize because it was one of the equations in the card sort in the Desmos activity that you just did. So someone may look at this equation and think, well, can I combine this anymore? Can I simplify this equation? And so maybe they look at it and they think, well, 4x cubed and 8x squared, why don't I just add those together and get, well, 4 plus 8 is 12. And then 3 plus 2 is 5, so that's maybe 12x to the 5th power now. And then we've still got plus x and minus 10. And then maybe they think, well, I can keep going. So I can add 12x to the 5th plus x. So we understand that there's a number 1 here. So maybe when we add these, well, 12 plus 1 is 13. X to the 5th plus another x is, I don't know, x to the 6th. Minus 10. Oh, maybe we can even do one more thing. Let's see, 13 minus 10. Well, I know that's 3, and I guess that's still x to the 6th. So, the problem with this, though, is that this is wrong. So, let's talk about why. So this has to do with something that are called like terms, and you've probably heard this before in other math classes. So this video is meant to be a little refresher about what like terms are. So let's start with something not so mathy. So an equation like this, 2 apples plus 3 apples plus 1 orange. So I see 2 things here that are alike, right? We've got 2 sets of apples. So if we add 2 apples and 3 apples, well, we would end up with 5 apples, right? So then we've got 5 apples and we've still got our 1 orange. So then can we add these together anymore? Are these alike? If we combine these together, would we end up with 6 of some other kind of fruit? Well, no, that wouldn't make sense, right? We can't combine 5 apples with 1 orange. They're not going to combine to form 6 of something else. And so this equation is written as simply as it can be. We can't combine these anymore. So in math, the idea of like terms is similar. So the way that we define like terms, well, first, they need to have the same variable. They also need to have the same exponent. So some examples of things that are like terms would be these. Notice that they all have the same variable, which is y, and they all have the same exponent of 2. So these could be added or subtracted together because they are like terms. Some examples of things that are not like terms, so some unlike terms. Notice that some of these have different variables. Some have x and some have y. And they also have different exponents. So an exponent of 2, an exponent of 3, and an understood exponent of 1. So these are examples of unlike terms. So going back to the equation we started with, notice that, well, these first 3 terms, they do have the same variable. They all have an x, but they have different exponents. So we cannot combine any of these terms. And so this equation, this is written as simply as it can be. So I'm going to circle that. We cannot combine those terms anymore. This equation is already written in its simplest form. So let's look at just a couple examples of things that are like terms and maybe unlike terms. So we will start with this. So we've got 4x squared plus 3x squared. So let's ask ourselves, are these like terms? Do they have the same variable? Well, yes, they both have an x. Do they have the same exponent? Yes, they both have an exponent of 2. So that means we can add these together. So to add them, 4x squared plus 3x squared, well, 4 plus 3 is 7, right? And then this is still an x squared. So I'm going to go back to our apples example for a second. So when we combined 2 apples and 3 apples, notice this is still an apple. It didn't become like apple squared or something, right? So over here, when we combine our like terms, notice that the variable and the exponent stays the same. So we have 4 of this thing, 3 of this thing, now we've got 7 of those things, 7x squared. So let's look at a subtraction one now. So notice those are the same 2 terms, but now we're subtracting. So again, they are like terms. They have the same variable and exponent, and so we can subtract them. And so 4 minus 3 is 1, so this would be 1x squared. All right, another one to look at. what about multiplication? What happens here? So if we're thinking about multiplying, well, 4 times 3 we know is 12, right? But what would happen with the exponents when we multiply? Would our answer still have an x squared, or would it be something else? So first let's consider this 4x squared. What that means is 4 multiplied by x squared. And x squared means x times x. So another way of writing that is like that. 4x squared is the same as 4 times x times x. And with 3x squared, we could rewrite that as 3 times, and x squared means x times itself 2 times. And let me put our multiplication symbol in the middle. So now if we multiply this together, 4 times 3, like we said, is 12. And then we've got 12 times x times x times x times x. So I'm going to write all of those. X times x times x times x. And then another way that you could write that, a simpler way of writing it, would be 12 times x to the 4th power. So notice that when you're multiplying, the exponent does change. Whereas when you're adding or subtracting like terms, the exponent stays the same on the variable. All right, let's look at a couple more. So 2x plus 5x squared. So again, let's ask ourselves, are these like terms? Do they have the same variable? Well, yes, they both have an x. Do they have the same exponent? Hopefully you're noticing no, they do not have the same exponent. This one has an exponent of 2, this one has an understood exponent of 1. So therefore we cannot combine these. And I'm going to write that. We cannot combine these because they are unlike terms. So what about with subtraction? Same two terms we just looked at. So just like we can't add these two together, we also cannot subtract them. So I'm going to write once again, we cannot combine because they are unlike terms. But can you multiply these two terms together? So can we do 2x times 5x squared? They're not like terms, we've established that. But what do each of these things actually mean? So 2x, if we rewrite it like we did up here, well, that means 2 times x, right? 5x squared, that means 5 times x times x. So if we multiply these together, well, 2 times 5, we can multiply those, that's 10. And then we've got x times x times x. So times x times x times x. And we could rewrite that a simpler way. That would be 10x to the 1, 2, 3 power. 10x to the 3rd power, or 10x cubed. So notice that you cannot add or subtract unlike terms, but you can multiply them. All right, so in summary, what we've gone over here in this little video. So in summary, to add or subtract, you must have like terms, which means you must have the same variable and the same exponent. And so some examples that we looked at, we can add 4x squared and 3x squared, which would be 7x squared, because those are like terms, whereas these have different exponents, and so we can't combine them. They are unlike terms. However, you can multiply unlike terms. And so the example that we looked at there was something like 2x times 5x squared, which you can multiply together to get 10x cubed.